Welcome to the course of Mechanics of Solids. This is our first lecture. I am a PhD structural engineering student in University of Leeds. I have a special interest in mechanics of solids. I've been working on this for a few years, but from now on, I want to learn it together with you people. Our first question should be, why are we learning this subject? You know, it is well said that a journey becomes easier if you know that the destination is worth trying. Mechanics of solids is a bit daunting for the beginners. I don't really understand these things. But trust me, it becomes very easy and fascinating once you master the basic concepts. However, to get ready to put in the effort, you must know where this can lead you. So in this video, I have only discussed some of the possibilities of where this knowledge or skill can take you. Beginning is always humble. For most of this course, we'll discuss the various types of stresses and strains in beams and columns. If you don't know about what is stress or strain, don't panic. In the coming lectures, we'll start from very basics. But most of the mechanics of solids part is the discussion about the flexural, shear, and torsional stresses in beams and their interactions. And then some of the discussion will be about the compressive stresses in columns. But another question is that where can it lead? Where can it lead us? What are the possibilities? Let's try to answer this. From houses to multi-story buildings. You must be watching this video in your home or college or dorm. What is it? A building designed by someone. An ensemble of beams and columns and other structural elements which have been analyzed and designed using mechanics of solids. The shopping malls, the hospitals, or even the set of your favorite movie became a reality because someone conceived and designed using the principles of MRS. Where can it lead? Capitol Gate, also known as Leaning Tower of Abu Dhabi, is a feat for eyes. Designed to resonate with the environment of the city, the waves and the sand dunes, it must have been analyzed by structural engineers for the stresses and strains due to the massive loading it has to endure. Burj Al Arab is one of the tallest hotels in the world, constructed on an artificial island. Is it only architecture or a dream turned to reality by applications of MOS? Have you ever found yourself caught in a traffic, getting frustrated? Busan, a city of South Korea, found the solution of its traffic congestion by constructing a bridge in the sea. Yeah, a bridge in the sea. It must not have been an easy task, but it was done. It stands today, battling against the winds, water, traffic, and environmental loading because someone has designed it to resist all these. This one is my favorite now. Golden Gate Bridge, a suspension structure. It opened in 1937 and was the longest suspension bridge in the world until 1964. The winds would have torn it to pieces from the day of its erection had it not been properly analyzed for the tensile stresses it had to carry. By the way, the Coman Narrow Bridge stands as an example of failure of a designer or failure of analyzing the stresses that can occur in it. It failed due to resonance. The natural frequency of the structure was the same as the force frequency caused by the winds. So, excessive vibrations were the reason of the failure of this bridge. We have discussed about the bridges and buildings, but this list is not exhaustive. Tunnels are one of the most useful but difficult to design structures. One such tunnel is smart stormwater management and road tunnel in Malaysia. It has been designed to carry stormwater and traffic at the same time. It has three chambers. Two are open for traffic and one for stormwater in normal operation. However, in case of a flood, it gets closed for the traffic, and all the three chambers can carry water. Again, an engineering marvel, because because the soil was karstic limestone covered by alluvium. It was not an easy task to design this tunnel, but then things are getting a bit crazy, right? You must be thinking like a structural or civil engineer and an aircraft design, but this is a reality. A structural engineer, obviously you have to specialize in this thing, has a role to play in the aerospace design of aircrafts. We need to analyze the aircrafts for stresses and strains, much in the similar way as we have to analyze a building for the dynamic stresses. But again, this is a very specialized skill. It can be mastered once you have a very strong grip on the basics of mechanics. The design of an aircraft is a complex and intricate process that requires meticulous balance of engineering principles and creative innovation. It plays a crucial role in this endeavor, ensuring that the aircraft's form and function align harmoniously. The most weird application of mechanics. But in reality, if you have ever dreamed of working for NASA, you need not be an astronaut to get involved. Launching a space mission is a highly complex task that civil engineers can support, from designing and manufacturing mission command centers to facilitating launches. Civil engineers played a massive part in constructing the International Space Station, which has assisted scientists in learning more about other planets and has even improved life on Earth by helping develop better vaccines and making inoperable tumors operable. So, I would like to end with this verse. Do you not see that Allah has subjugated to you what is ever on the earth? This is from Al Quran, Surah number 22, ayat number 65. What does it mean? That the things available within this universe have been made on our disposal. Universe is open for you. Let's learn how to utilize it for the benefit of humanity, and surely MOS is one of the skills that is going to benefit us in this journey. Thank you. I would like to see you all in our next video.